we need to determine the optimum number of rain gauge stations in a basin. Now in this basin there are 6 rain gauge stations A, B, C, D, E and F, and the normal annual rainfall depth for each station is given. Now this is the average of this normal annual rainfall depth. Now what do we need to find out? We need to determine the optimum number of rain gauge stations to be established in this basin if it is desired to limit the error in the mean value of rainfall over the catchment to 10%. This is the formula we'll be using. N is the optimum number of rain gauge stations to be established in the basin. CV is the coefficient of variation of rainfall of the existing rain gauge stations, and P is the desired degree of percentage error in the estimate of average depth of rainfall. Now, coefficient of variation is standard deviation divided by mean. So, first of all, let us find out the standard deviation. So, standard deviation, this is the standard deviation, 19.59. This is the average value, 70.083. So, the coefficient of variation in percentage, we'll find out first. 19.59 divided by mean is 0.28. So, it is 27.96 or 28%. So optimum number of rain gauge station is equal to CV by P whole square. CV divided by P. It is desired to limit the error in the mean value of the catchment to 10%. So I'll divide it by 10 whole square. 7.82. This is the value of N. Now there are 6 rain gauge stations at present. So we need 7 or 8 rain gauge stations in this basin. 7.82, if we round this number, it will be 8. So at present there are 6, we need 8 or at least 7 rain gauge stations. Now we'll do a similar example. Let us solve this example. Now, determine the optimum number of rain gauge stations to be established in this basin if it is desired to limit the error in the mean value of rainfall to 10%. So similar to the previous problem. So zones are given. The isohedral map is also given. There are 1, 2, 3, 4, 5 and 6 zones. Area of each zone is given. This is the total area. As you can see, this is the line of equal depth of rainfall. 75 centimeter, 50 centimeter, 25 centimeter. This is zone 1. This is zone 2. And this is zone 2. This is zone 3. Zone 4. This is zone 5. So in zone 3, for example, there are 1 and 2 rain gauge stations. In zone 2, there are 3 rain gauge stations. And I can't see any rain gauge stations here, so there are no rain gauge stations in zone 1. In zone 4, there is 1 rain gauge station D, and in zone 5 there is also 1 rain gauge station. So what is the percentage accuracy of the existing network in the estimation of average depth of rainfall over the basin? So first we'll determine the optimum number of rain gauge stations. So we'll be using the same formula. N is equal to CV by P whole square. So these are the stations, and normal annual rainfall at each station is given: A 60 centimeters, B 92 centimeters, C 62 centimeters, D 45, E 20, F 86, and G 68 centimeters. Now, standard deviation 24.39. So this is standard deviation. Now coefficient of variation in percentage, it is equal to standard deviation. First we'll need to find the average. So average, this is 61.85. This is equal to 24.39 divided by 61.86 multiplied by 100. So this is the coefficient of variation. Now 10% is the desired degree of percentage. Yes, desired. It is desired to limit the error in the mean value to 10%. P, desired degree of percentage error in the estimate of average depth of rainfall. So we have P as 10. Let's write this as P. So N, optimum number of rain gauge stations, will be equal to CV divided by P whole square. It is 15.55. Let us round this number. It will be 16. So 16 is the optimum number of rain gauge stations required in this basin. Now let us write the zone. There are 6 zones: 1, 2, 3, 4, 5, and 6. Okay, 5, 6. Now the area of each zone, I'll write it down: 63, 278, 63, 278, 389, 220, 220, 55, and 33. 33. So the total is equal to sum of all these values. This is the area, this is the zone. Now we are trying to arrange 16 rain gauge stations properly in this watershed. At present, okay, now area in decimal. Just find out the percent. It is 63 divided by 1038. It is actually 6%, but I'll keep it as it is, 0.06. I'll just anchor this. So its total will be area 63 divided by 1038, so it's 6%. I'll keep it as it is because I need it in decimal form, 0.06. I'll just anchor this 63 divided by 1038. Okay, the total will be 1. Now I'll multiply area, multiply it with n, which is 16. N is 16, optimum number of rain gauge stations. So this multiplied by 16. So the total will be 16 here. Now rounded value, this will be rounded to 1, this will be rounded to 4, 6, 3, say 1, and 1 to 5, 11. 1 plus 4, 5 plus 6 is 11 plus 3 is 14, 15 and 1 more. 0.51 is rounded up to 1. So 16 rain gauge stations, existing rain gauges. Existing rain gauges in zone 1, well, there are no rain gauge stations in zone 1, 0. In zone 2, there are 1, 2 and 3 rain gauge stations. In zone 3, this is zone 3, this is A, C, there are 2 rain gauge stations in zone 3. 2 rain gauge stations in zone 4. Zone 4, this is zone 4. There's only 1 rain gauge station in zone 4 and 5. And in zone 6, there is no rain gauge station. So it is 0. So existing rain gauge stations are 7. 1, 2, 3, A, B, C, D, E, F, G. 1, 2, 3, 4, 5, 6 and 7. Now, let us arrange new rain gauge station, rain gauges. Now we'll arrange one here. Just there's one missing station here. See, we need one rain gauge station. There is no rain gauge station here, so we've written 1 here. So there existing rain gauges are 3 in zone 2, so 1 more is required. Here there are 2 rain gauge stations, we need 6, so 4 rain gauge stations, 4 additional rain gauge stations are required in zone 3. In zone 4, again, 2 rain gauge stations are required, and one is already present here, so no additional rain gauges are required here. And here again, 1 minus 0, 1 rain gauge station. So this will be additional 9 rain gauge stations will be required. At present there are 7, so 9 rain gauge stations will be required, and this will be its arrangement. One in zone 1, another one in zone 2, 4 in zone 3, 2 in zone 4, no rain gauge stations required in zone 5, and in 6, 1 rain gauge station is required. So now what is the percentage accuracy of the existing network in the estimation of average depth of rainfall over the basin? The percentage accuracy, percentage error. Let us find out the percentage error first. This is the formula. P is equal to CV by root N. So we already know CV. It is this value 39.43 divided by square root of N. N is the number of rain gauge stations, not the optimum one. The rain gauge stations before the new rain gauge stations were decided. So in this basin there are A, B, C, D, E, F, G, 7 rain gauge stations. So I just divide this with square root of 7. So 14.90 is the error. So accuracy will be equal to 100 minus 14. 85.10% is the accuracy. The percentage accuracy of the existing network. This is the existing network, and this is the new arrangement.